Okay. So today is midpoints and distance formula, and at the end I'm probably going to add on one little bit extra, because the midpoint is just, we have two endpoints, right? Two endpoints. It's just the midway between it, the midpoint. And if I were to say that this midpoint is a certain ratio from this endpoint, how far would you say it is, the midpoint is, as far as the ratio goes from this endpoint, in respect of the entire length here? Half, right? So what we're going to be talking about tomorrow, and I'll probably elaborate today a little bit, it's the it's really the ratio point, distance from an endpoint. The midpoint is just special, it's midway, so it's a ratio of 1/2, but it is right in the middle. Okay, so we are creating a ratio between them, and the midpoint's pretty straightforward because it's really, what we're going to learn later, is just the average between x and y. Okay, pleasure. So just to review here, we have the coordinate plane, Cartesian coordinates, x and y. And this is our x, this is our y, of course. And if I have these 2 points, -2, -1, and 3, 1, okay, if I asked everybody, you know, what is the x value, some people might say -2, some people might say 3, because there's now 2 points. There's an x here and an x here. So the way we distinguish the label is x1, y1, x2, y2. It's just group number 1, group number 2. Okay, you just got to group them that way. And just a quick note, I don't think anyone is going to miss this one, but just in case, x squared is not the same as x sub 2. Okay, it's not an exponent. It's not you know, it's not like from combinations where we had our n and r values kind of as a sub note. It's just the notation to show that this is x1, y1, this is x2, y2. Just the grouping. Okay, so that's the review. Now looking at the midpoint here, what we're doing, we're just finding the average of the x's and the average of the y's. Just the average of the x's, average of the y's. So if 2 people in here are 14 and 16, what's the average between those 2 numbers? 15. How do you find that algebraically? What do you do with those 2 numbers? Add them together, then what? Divide by 2. So the same thing is going to work with our point values here, with our different order pair values. What we're going to do is just add together our x values, divide by 2. Add together our y values, divide by 2. It doesn't even matter if there's negative numbers involved. In this case, you'll basically just combine the 2 numbers, whatever they are, divide by 2, and that gives us our midpoint. You can think about it. What we're doing today, a lot of what we're doing today, is looking at a line segment and saying, well, any line segment on your Cartesian coordinate grid you can make into a triangle. You could drop it along the vertical and make a dashed line here along the horizontal. It's a right triangle, right? So if I had to find the midpoint between these 2, tell me where, as far as our y coordinates go, would this be the y coordinate for the midpoint? Right here? No. Is that the midpoint? No. How about down here? Is this the midpoint? No. Where do you think it would have to be? Tell me when to stop.
Right there.
Let me do it again. Okay, so what you're saying is you find the halfway point along your y values, right? The halfway point, and that's going to tell us one hint. How am I going to find the other value? Tell me where the midpoint is for this. Tell me when to stop. Okay, so we know that this is approximately the midpoint, so we would just make another dashed line here. So you see, to find the midpoint, all we're really doing is we're looking here to see what is the average of my y values, and over here is the average of your x values, right? That's all we have to do. So we're given 2 points. We're given 2 points. So coming back to that, the midpoint is adding the 2 x's, divide by 2, add the 2 y's, divide by 2. We're finding the average of each. So let's go ahead and do that for this one. I want you to do this algebraically, and then we'll prove it over here graphically. So go ahead and knock that out really quick here. 1, 2, negative. So we have -2, -1. And we have 1, 2, 3. Whenever you're doing graphs like this, if you don't have graph paper, it doesn't have to be perfect. We want to find the midpoint of that segment. Okay to see this? Okay, algebraically, just coming back to that, let's add together, let's call this first x1, y1. This is x2, y2. That's your first step, is to always label it your 1 or your 2 group. And then let's add together our x's. 3 plus a negative 2 over 2. And let's add together our y's. Making our new ordered pair here. We got 1 plus a negative 1 over 2. So from this, midpoint formula is pretty quick. We can really quickly come to our final. 3 plus minus, this is minus 2, is 1. So we get 1/2. And then we have 1 plus minus 1, so this can be 1 minus 1 is 0, divided by 2 is 0. So let's see if we had this right. Let's see, 1/2 for x, 0 for y. It's approximately my midpoint right there. It's not perfectly to scale, but we know that that's our midpoint, 1/2, 0. So you can confirm it really quick by jotting down just a quick graph to see if it is in the middle. That looks like it works. Yes, done. Okay, midpoint formula, you've seen this before, right? Seen this before? Maybe? Yeah. Okay, we're gonna take it one step further. This is slightly different. Now, instead of knowing the midpoint of the segment, we want to know the whole length of the segment. So if we look at this, remember that we learned in the warm-up, reviewed it, that this is the Pythagorean theorem, and its integral and totally connects with what the distance formula is. This is the distance formula. So put the star around this. This is the main one we're using. It just is derived from the quadratic. So let's see, 10 seconds, go and talk with your neighbor. How do you go from Pythagorean to the distance formula? How are we going to do it?
Yeah.
You just like flip it around and the square root. You turn the D or the square root over those, so you just like it like.
You just square root both sides.
We don't have.
Okay. All right. What? Let's see. How do we go from here to here? Anybody can real quickly elaborate. What'd your group come up with? Anybody have a group that came up with something? Nothing, nobody, nothing. Monday, yes?
Well, you square rooted C, so that's why you got square root on the A squared and B squared.
Excellent. This is C squared equals A squared plus B squared. What you're saying is we could square root both sides.
Yeah.
What happens to the C squared?
It becomes a C.
Just,
Or,
yeah, it does become a C. Because it's an inverse operation, squaring square root. Good. So this is the same as this. They just changed the C to be a D because they're talking distance. Okay. So don't get tripped up on that. Now, this is going to be pretty straightforward as long as we can make our triangles out of any of these. So let's see. We have negative 3, 2. And let's see, so that's negative 3, 2, and 5, 1. So we have this going on. Now, how are we going to make our triangle? You can make it in any way you want. This is just going to help us quickly figure out what the lengths of a triangle are. So should I make the triangle above the line or below the line? Really doesn't matter. No, it doesn't matter right there. So let's make it just here. So we made our triangle. It's a right triangle. We want to know what this is. So if we find what this length here is, and this length, then we're able to figure out those lengths and use distance formula, and we're done. So looking at this, first off, distances in this case, we're always going to count as just positive values. We're looking for a distance, right? You can't have a side of a triangle that's -5. So everything that we're doing here, everything we're trying to figure out, is just, we're going to take the absolute value of it as well. So looking here, to find this distance, I'm looking at my x values, and what I'm going to do is basically take 5 and minus the -3 to it. So the exact, or the total distance is going to find the difference of it, and then you have to take the square root. So this is going to be 8. Let's find this one. Let's see. This is the absolute value of, let's see, 1 minus 2. 1 minus 2 is -1, so we know that this is 1. So this here is 1. That's how we found that. This one is 8. That's how we found it. You're just subtracting them. And really, as long as you keep the same, notice the first one I did. The first value that I'm subtracting to get my x's, I subtract the 5 minus the -3. For here, I subtract the 1 minus the 2. So I'm subtracting the first number in each of ones here is going to be from the same point. So we're going to go ahead and find that we have a triangle that is like this. Distance, 1 squared plus 8 squared, root 65, and I think that's 8.0. 8.06. Okay. Let's do one other attempt with this. Just because this last part's a little trickier. All right, so with this, we're going to go from, how about 2, 3 to 4, -1. First label your x1, y1, x2, y2. Okay, I'm going to go ahead and say this is x1, y1, x2, y2. So, remember, for finding the side lengths here, all I need to do is to find our change in x. We're going to go ahead and take the absolute value of x2, 4, minus x1, 2. So we get a change in our x value of 2. Easy. Change in y. y2, -1, minus y1, 3. So we get -4, but the absolute value of that is going to be 4. So we got the change in our x, we got the change in our y. So really what I know here is, I have, it doesn't even matter if the triangle is perfect here. You can see it goes down. Something like this. Looks like we have change for x of 2, change for y of 4. So now we know our a and our b. All I did was find the sides of the triangle. Let's say that this is the 2, 3. And that is the 4, -1. So now we just go to the distance formula. D is equal to the square root of 4 squared plus 2 squared. That's the square root of 20. And from there, we're going to go to find the decimal. 20 square rooted 4.47. All right, I want the answer in the hundredths place like that. So all we had were the 2 points given. I found the change in my x, 2, change in my y, subtracting and taking the square, sorry, the absolute value. And then from there, you can use the distance formula right off the bat. All right. You know, I'm going to bring the second part of the lesson tomorrow. I'm just going to hit it up tomorrow. So this is a good start. Number 8, when you get to the homework for you guys, number 8 is the challenge question. That's what we're going to follow and do tomorrow. So that one will just be a challenge for you. If you don't know how to do it, don't worry. We'll get to it tomorrow. All right, that's it. Everything's on the iMath doc. Because we don't have our new workbooks yet, you have to access the iMath. And I'll put it up here as well. And that'll be it. All right, great.
Headphones?
Yeah.